Okay, we are beginning the 5.2 complex numbers and division section. If you have the files from Microsoft Teams, you should be able to access this, and you can print off page 10 through 15. Well, I'm not really going to talk too much about page 10. This first page, this is just a review. I mean, this one right here is a little complicated, but just as kind of a refresher, that's going to be 5i there because it's 5 times the square root of -1. And then you have, a lot of other things going on there. I'm not going to get into that. All right. So I'm going to go straight to the second page. And we're going to learn about a new topic here called the complex conjugate. And it's pretty straightforward. There's not much to it. I don't know if my voice is too loud. I just have this microphone right up against me. So if I'm talking too loud, just turn my volume down and we'll be all right. Okay, so just as kind of a heads up, I'm going to open the chat if you want to talk to me. But otherwise, after rewatching yesterday's video, I'm not going to allow any more audio. Just as, pretty much I got the message a while ago. I got the message from one of my students that typed in she was outside. Well, that's how I would prefer you to speak. If you can, I'm going to have to just pull the plug on that, on the audio. Now, I'd love to teach you personally, but I'm not going to, good morning. I'm not going to have any audio, and I think we probably understand why from what happened yesterday. So I'm not going to, these videos are played over and over again throughout the course of several years, and other teachers use them. And so we're going to be talking about only what this is discussing. And we're going to keep it to 40 minutes. And we're just going to follow the structure the best that we can. And thank you for typing in the password. I'm trying to do that because they're saying that Zoom is being hacked by some crazy people. So I'm not crazy, so I don't have time to be hacking anybody. Let's look at this. First, let's look at the definition of the conjugate of a complex number, okay? So this is something that you're actually going to need to know. And I remember learning this whenever I was in high school or maybe junior college. I think it was high school, but it stuck with me, and I've used this so many times, even all throughout my college career, all the way up. I mean, you're going to have math classes that you're going to need the complex conjugate for, and you're not going to know how important this is until you actually get to that point. So make sure you're paying close attention. I want you to understand that this is the a plus bi is the standard form of a complex number. Well, the complex conjugate is basically you're just putting a minus in the middle instead of a plus, and there's going to be a reason for this in just a minute. It's very simple, but we'll discuss it in a minute, exactly what's happening here. It says, for any complex number, a plus bi, the complex conjugate is simply a minus bi. You notice that the real part remains the same. So that means the a does not change, okay? And the sign is changed for the imaginary part, okay? And so in this case right here, we have a complex number. Obviously, this is 5 minus 3i. They're trying to trick you here, okay? So what you remember, that minus sign is sticky, so you're going to say 5 plus negative 3i. So, I mean, you can look at it like this, okay? A, which is 5, and then bi. Well, b in this case would actually be negative 3 because that minus sticks with that 3. So this is the complex number. Don't let yourself get confused here. Basically, what they're saying is instead of adding here, like this part, all right, you would put, instead of a plus, you would put a minus there, okay? So the complex conjugate would be It's going to be A minus BI. Remember, B was -3, right? -3 is B. So we're going to put, so let's see, we're going to put the minus there, just like they're saying here. So it's going to be A minus, and then -3, and then I. And you should know what minus negative is. Minus negative is positive. So we're going to have 5 plus 3i. All right. Now let's move on to this next section here. So now we're trying to figure, the whole point of this is we're trying to figure out how to calculate the complex number and the complex conjugate. I want you to understand it's much easier than it looks. If you just take this section right here and this section right here, look at the difference between those two. That's the only, all you have to do is just change the sign in between, okay? I made it so complex there, okay? But I'm trying to show you the basic idea of what's happening here. So basically, when we get down to it, you can just change the sign in the middle. That's all there is to it, okay? All right, and so look right here. What do you think is going to happen here? The answer is going to be -6. You're going to have a 2i over here, obviously, but what's going to be in the middle? So we've got, for any complex number that looks like this, which in this case it would be blah, 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 right? So it would be like -6 plus -2i. You're adding these two together, and that's a sticky minus sign. It stays with the 2. So you've got a plus bi. B is -2 in this case. Then you're going to come over here and say a minus bi. And so -6 plus 2i is what I come up with. And if you'll look, I'm going to cover up all the mess that I don't need here. Look at the difference. Just exactly what you were thinking earlier. You're just going to change the sign in the middle, okay? So you've got a complex number on the left, and you've got a complex conjugate on the right, okay? All right, so let's move on down. All right, remember, every number has an imaginary part and a real part. We talked about that yesterday. In this case right here, we have nothing but an imaginary part. Well, there is a real part. It's just not there. It's hidden or invisible. It's 0 plus 2i. So what's the answer going to be? Complex conjugate, you guessed it, 0 minus 2i. You're just changing the sign in between. It's very simple. All right. So, and now if you wanted to actually simplify this down as much as possible, you do not need this 0. Okay. So this is going to be equal to -2i. So if this is equal to 2i, then the complex conjugate is going to be the opposite of that. Okay. Just keep thinking opposite. Okay. So in this case right here, we've got an imaginary number plus the real number. Well, what happens if we're supposed to have a plus bi? We're supposed to have, like, the standard form is the real number plus the imaginary number. Why not just twist it around? Use the commutative property of addition and just flip these two things around. So you're going to have 21 plus what's in front of that I? How many i's is that? That's one I, right? So you're going to have one I. So if you were to rewrite this in, like, I would call standard form, you would write it like this, and then you come over here and say, okay, what's the conjugate of that, the complex conjugate? It's going to be this and this with the opposite sign in between. So we're going to put the minus sign in between. And if we simplify it out, you can simplify it out to be 21 minus I, and done. Now look really close, the difference here, okay? So it started off like this, and it ended up like this because we twisted around that, the real and the imaginary. I'm just trying to keep it, just like it always has been. Just here, 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 here. Everything's real, then imaginary, real, then imaginary, real. That's imaginary than real. That's why I twisted that, okay? All right, let's move. I'm going to leave this up on the screen for just a second to let you get a chance to copy it. And I'm going to type in case somebody else tries to hop in. I'm just going to come over here. Just keep if you have a question, pull click the little button at the bottom that says chat. And then, like, if I'm going too fast or you know an answer, just type the answer in. You know, that'd be even faster. But like I said, I'm going to keep the audio off for a while because this affects more than just us, and we need to make sure that that the videos come out and are reusable, and they're not just uh, a one-time thing. All right, so let's look at this. So it says, what happens when you multiply a complex number by its complex conjugate? Remember yesterday we were talking about multiplying a complex, meaning an imaginary number by itself, or I think we talked about that a little bit Monday. And then we noticed that it was, if you take I and multiply by itself, you get I squared. And I squared we found out was -1. It came out to be real, so imaginary turned out to be real. And then yesterday, we talked about multiplying something like, I'm just making stuff up here. So you have two complex numbers here that we multiplied together, and we used what was called the FOIL method, okay, to figure out the answer there. And we came out with something that was a complex number on the side. So it was some real number and then some imaginary number. Okay, so now what's going to happen here when I multiply this imaginary number by this complex number by this complex number? Now, I don't know if you remember, but I don't know if I was able to speak to you about it in my class in Algebra 2. I want you to remember something here. Okay, I wanted to speak to you about this. This looks a lot like a quadratic, or basically two binomials multiplied together. And I want you to remember something called difference of squares. I want you to notice the similarity between difference of squares and this. Now, remember, I is not a variable. I is a constant. It is it's always the square root of -1. Well, in this, and I don't want to confuse you too much, but I just want you to see this setup here, okay? Okay, let me think. Okay, so we got A plus B and then A minus B. Okay, so with difference of squares, you have something that looks like this, and it's two binomials multiplied together. Now, these would be variables in this case, but I just want you to see the similarity between this rule and what's fixing to happen over here. You can already see A plus B and A minus B. Well, if you look at this, the difference of squares, that's called a difference there, and these are squares on both of the ends, okay? So if you're multiplying the first term by itself, you get A squared. If you multiply the last term by itself, you get B squared. But the way this works out, it's called the difference of squares. So it can be split up into these two binomials like this, where you have one's positive and one's negative. So it's like, here's a number and here's its complex, here's its conjugate, okay? And so same idea here, just kind of keep this in your mind off to the side. We might come back to this little part right here in just a minute. That I just wanted you to know where my mind was going there when I saw that. Okay, and so let's look at what's happening here. So we're going to do FOIL method just like we did yesterday. So we've got first, we've got outer, we've got inner, and we've got last, just like we did yesterday. So we're going to do the first was A times A. The outer was A times negative BI. Okay, so it's going to be that negative stays with that B there. And then your inner terms are going to be BI times A. This right here. So BI times A. And then the last one is going to be BI times negative BI. Okay. So BI times negative BI. Right? Now we're just going to work this out. So here's the FOIL method. First, outer, inner, last. First, outer, inner, last. So A times A is A squared. A times negative BI is negative AB I, okay? Now, keep in mind, this is, I'm going to put an underline right there, okay? Keep that in your head for a second. So over here, this is going to be a positive A, B, I, just like that. Think of these two terms as equal. I mean, ours, similar, not equal. But in this case right here, this is a minus B squared I. Now, be careful here, though. It's not just B squared I. It's minus B squared, and then the I is also squared because you're multiplying the I by itself too. Now, remember yesterday I circled that I squared for a reason, and you should probably already know what I squared is. You probably have memorized it by now. All right, so I squared is -1, that's for sure. And let's go over here and look at this. What happens with ABI minus ABI? You see what happens here? These cancel out. Just like in the difference of squares, there's no middle term here. It's only a square on one side and a square on the other side with a minus in the middle, just like that. So you literally could have done this in your head had you memorized this right here already. Okay, you probably could have gotten this answer. And you'll see in just a second what the difference actually is. Okay, all right. So, all right. So remember, I squared is -1, and we're going to pull down what we have here. So we're going to have A squared there. We're going to have minus B squared. But remember, the minus B squared is multiplied by -1. So I want you to pause just a second. Let's take a middle 5 seconds and just kind of look over what's happening here. FOIL method, first outer inner last, A squared. Then you got these middle terms that cancel. Then you come over here and you got -B squared, I squared. I squared is -1. Okay, now we've got all this mess going on here. All right, now I want you to understand you can multiply all of this right here together. And so remember, the difference of squares looks like this, but because I squared with the minus in the middle, but because I squared is actually not a constant. I mean, it's not a variable, it's a constant. It's -1 all the time. That's going to change what's going on here. So the answer is going to be A squared plus, see these two minuses there? Minus negative, so A squared plus B squared. So this is the difference between this and the difference of squares. And what made it different? It was this imaginary number turning into a -1, okay? That's what made it different. But I mean, the concept is still the same, okay? You can still see, look, A squared minus B squared, just like it is over here, all right? But that right there that threw the whole thing off and put a plus right there. Okay, so this is, yeah, okay. So now the final answer is A squared plus B squared. Now, if you'll notice, there is no I anywhere in this at all. So what is this? It's a real number. All right. So let's go back and talk about what the question says. It says, what happens when you multiply a complex number by its complex conjugate? It always turns into a real number. And so that's why this is important to know, because you can always turn something imaginary into something real by multiplying it by its complex conjugate. Okay? It doesn't matter what it is. So let's go down here. And remember, and when you have something that can be turned into a real number, you can add it, subtract it, multiply, and divide it by anything. All right, and so it's very usable. Multiplying any complex number by its conjugate will yield a real number. Okay, so let's go down here and move to the next section. Now I'm on this. I don't know if you have this printed off, or if you do. It's from that file that I gave y'all, and it's 5.2-203. I think this is like page 12 or something like that. I'm not really sure, but that's kind of where we're at right now. So I'm just going to move over and kind of talk about, now we're probably going to only be able to cover half of this today, and then because we're already 22 minutes in, and then we'll probably cover the other half on Monday. And there's also, if you'll notice when you print this stuff off, if I tell you to do print off page 10 through 15, page 15 is like homework problems. I'm not going to hold you to that. I mean, you can practice that if you want. What I am going to hold you guys accountable for, you can practice these if you want, okay? I'm just going to hold you accountable for what I'm doing only on this video, like what I actually can do with you. All right, this over here is just extra practice. If you want to try something, it it doesn't hurt to try something new, okay? And you're going to make a mistake. You're going to mess up somewhere down the line down here, okay? You're going to make a simple, easy mistake, but then you're going to learn from it, okay? If you just go back and try to practice this stuff, there's no real way I can hold you accountable to this homework. The only thing I can hold you accountable to is what I am writing with you. So the way I want you to turn this in, and I'm going to show you something here. I don't know if I can go to my desktop. I'm going to go to my desktop screen just a second, and I want you to see something. I don't know if I'm still not sure how to work this. Okay. All right, so I'm having trouble trying to figure out how to share my my desktop picture. But if you'll go to Microsoft Teams, just like if you get those updates from me, you share your files from me there. Just take your phone and or if you have a scanner, you can scan this stuff. And then in a couple of weeks, I'm going to get it to the point where y'all can actually type something into a file. And then upload it like that PDF style. But if you can take a camera and just and take a picture of what you have handwritten, and then send that picture to me through Microsoft Teams. That'll be the fastest thing, I think. Okay. I said you could send it to email, but I mean it's probably just as fast to do Microsoft Teams. So let's go over here and let's talk about the complex conjugate again. All right, brighten it up a little bit. Okay, so in order to divide a complex number, divide by a complex number, we must turn the denominator into a real number. Okay, so let's think about this. Just yesterday we multiplied two complex numbers, right? We did the FOIL method and all that sort of stuff. So now you know how to add two complex numbers. You probably would know how to subtract easily. Okay. Yesterday we covered multiplication, and now the only thing left is division. Okay. So let's talk about how to work on this just a second. So we've got a complex number divided by a complex number. And so we want to turn the denominator into a real number. Now, why would we want to do that? Why would we? It goes back to this. Remember, I think I talked to y'all about this before, but every mathematician across the entire globe would shake in their boots if they saw you write something like this, okay? And just leave it like that, okay? So what this is, to them, it is an unfinished problem, okay? Because you're not supposed to have a irrational, this is an irrational number, negative, the square root of 2. You're not supposed to have an irrational number on the bottom of a fraction. Think about this. If you were to take a calculator like this, let me see if I can brighten this up a little bit. And what if you were to, instead of dividing by like 180 by 4, you took 180 and you divided it by 4.56984, and you just kept going. This is what an irrational number looks like. You're not supposed to divide by a number because you would never, ever get to the point where you could push the equal sign. Irrational numbers, you cannot divide by them because they're not easy. It's not like saying 8 divided by 4. Well, let's go back here. 8 divided by 4. Dang, what happened to my thing? Okay, so let me, so like this, 180 divided by 4, it stops. And then you push the enter button and you get an actual number. So this number at the bottom has to be real. And that's why every mathematician would be like, okay, that's not true. We need to change that. So how are we going to do that? We're going to multiply it by itself, basically. In this case right here. So you would multiply the top and the bottom by the same number. And the reasoning behind that you should probably know now is you can multiply by one, any number by one. And this is just a really smart way of making the number one, because what happens is these two square roots cancel out, and you get, like we said on day one, I believe, all right? If you square a square root situation here, you get these cancel out here, so you get 2 at the bottom, and your answer would be done. So this and this are the same exact thing. They're equivalent. See how much easier and nicer this is? Okay, so this is what's happening down here. So instead of doing square roots, you're not supposed to have a complex number on the bottom. You need something real, tangible to divide by, okay? And so how are we going to do that? Well, all right, so let's go over here in just a second and work the things out. So let's say it says, for any complex number, a plus bi, that's the standard form, b is not equal to 0. So in other words, if this was 0, you would have only real, no imaginary part, right? For any complex number where you actually have an imaginary part, that's what it's saying. To divide any expression by a plus bi, you multiply the expression by 1 in the form of this. So just like we talked about that, so you're multiplying it by 1 in this form, in a smart way is what it's saying. Just like we multiplied right here by 1 in this way, okay? So where a minus bi is the complex conjugate of a plus bi. So here's a, if you'll notice, look, the complex conjugate divided by the complex conjugate, okay? Okay, so now let's go over here and talk about this. So what would be the complex conjugate of not this number on top? I'm not worried about that number on top. I'm worried about the one on the bottom, because you're not supposed to multiply by a complex number. You need a real number to multiply by, okay? Or divide by, I'm sorry. So the complex conjugate, remember when we first started this video 30 minutes ago, we said that 2 minus 3i was the actual, the beginning complex number. Its conjugate, all you have to do is put a plus in, or change the sign in the middle, okay? So, just try and memorize that if you can. And let's remember to multiply in a smart way by the number 1, because the number 1 does not change what's happened here. This is just a smart way of you making this number down here real, okay? So now we're going to rewrite everything here, and this turns out to be exactly like yesterday when we worked out those problems, but it's I would say it's twice as tedious, okay? Because this up top is exactly, I'm gonna cover that up. This is what we did yesterday with FOIL method, remember? And then you've got this down here again, this down here, you would use FOIL method on that to figure that out. And then we're dividing these two things. So that makes it even more tedious, okay? Because it's more like 2 problems in one. But I want you to remember, there is something that you can memorize, all right? There is something that you can memorize. Remember that page before that will help you get this without having to use the FOIL method. You can just go straight into the answer and find the answer. And it takes practice, guys. It's just like playing the violin, or it's like playing the piano. When somebody sits down at a piano, if they have never played a chord before, they're gonna sound terrible. They're going to be very, very inefficient at playing the piano. But somebody who sat down at the piano a lot and practiced and practiced and practiced, they can sit down here and just zoom right through this. And people are amazed at how well you know your material, okay? And so like in this case right here, I mean, people like me who have done this over and over and over again for hours and hours and hours, we've become, just so good at it that we could just zoom through it and just leave everybody else in the dust. Well, that's what makes it hard as a teacher to go through this, is because part of me wants to answer this quickly. The other part of it that is a part of me is wanting to make sure that you get it. So that's the thing I want you to know. It's not about how fast I can do it, which I know I can do this quickly. It's about how well you understand what you need to know. So it takes time, it takes patience to learn how to answer these kinds of questions and know and see this kind of stuff before you get down here, okay? All right, so now let's go do the FOIL method on this. We're gonna do it straight, just like this is your first time doing this. So we're gonna take our time, all right? This may be the last thing that we do. I don't know. I'm not sure exactly how long this is going to take, but I do want you to see that you can probably get to the point where you don't even have to draw these lines anymore, okay? That's kind of where I want you to be honest, is to just figure out how to know this, the first, outer, inner stuff, without having to draw all this, okay? All right, so 1 times 2, that's the first, it's FOIL method, F-O-I-L. Outer is 1 times 3i. So that's going to be plus 3i. 1 times 3i is 3i, right? And then we're going to add again the inner terms. So it's going to be 2 times 2, which is 4i. And then the last term, which is 2i times 3i, which is 6i squared. And every time you write I squared, I want you to circle it like that, because I want you to remember, hey, wait a second, this means something, okay? What does it mean? You know what it means. It means -1, right? So that is -1. All right, so let's go, let's try this bottom one without doing the FOIL, you know, the bars like that. So let's try doing this. So we're going to take this one at a time. F-O-I-L. So we're going to do the first from the bottom. You can see it already. 2 times 2, which is 4. All right. And the last is, I'm sorry, not last, outer. So it's going to be 2 times 3i for the outer. 2 times 3i is 6i. And then the inner term, that's going to be right here. So it's going to be negative, that's a sticky minus there, -3i times 2, which is -6i. And then the last term, which is this term and that term, you're multiplying these two together. So it's -3i times 3i, which turns out to be -9i squared. Circle. Now, you know why I circled that, okay? All right, so let's go over here and work out the material here. So we're going to just simplify the best we can up here at the top. So you've got a real number, imaginary, imaginary, real. This is real, guys, okay? So we got 2. What's 3i plus 4i, right? 3i plus 4i is 7 i's, okay? All right, now this over here, this last term, this is going to be 6 and then I squared, but that's 6 times -1. That's what that is. So what is 6 times -1? It's -6, okay? All right, so let's come down here and do the next one at the bottom. This is real now. So we had a complex number here, and we multiplied by its complex conjugate by changing the sign there. This is really a smart way to multiply by 1. The whole point of this is so that this number down here can be an easy, nice number to divide by, okay? All right, so let's see what happens here. 4, 6 minus 6. Remember the difference of squares thing we talked about the other day or earlier? So go back and check that. Look at how that's similar, because there's no inner and outer terms, there's no middle terms here. It's only the first and the last with a minus in between. You see that? And notice these are perfect squares. See that? Okay. 4 and 9. So now let's check this out. We've got -9, and then I squared is -1 there. So this is going to be negative or -9 times -1. So let's simplify. That's going to be 4 plus 9. 4 plus 9 is 13. So that right there is all we needed to know. Everything else is pretty straightforward. So it's going to be 2 minus 6 is -4, and then 7i. All right, so here it is. This is my final answer. And now, all the mathematicians across the world are breathing a sigh of relief because you did the right thing. You did the right thing. You made the bottom of the fraction real, okay? So, same thing up here. Doesn't that just make you feel better? Okay, so we've got the square root of 2, and what would this be? The denominator there would be 1. What is that? That's real, right? So now everybody's good. Now let's take a second and notice that we are now 39 minutes in to the lesson, and I want to tell you thank you for being a part of this, and I want you to keep pushing yourself to learn this material, because this is only going to help you in the future with ACT and all of that. Like I said, you don't ever get better at something unless you practice. Practice, practice, practice. And if you don't make yourself do it, nobody else is going to make you do it. Okay, not at this point in your life, because you're out of school. And I'm going to wrap today up with this little real quick part here. If you want to work this later, you can. This is the beginning of how you would work this, and we're going to talk about tomorrow why this is where I would go. Why would I do this? Okay, so I'm going to tell you, have a good weekend, and we'll see you back Monday. I'm starting my geometry classes here in a couple of days, so make sure that if you're in my geometry class, also be a part of that. And y'all have a good weekend and stay safe. Okay, bye-bye.